All right, thank you everyone. Welcome to our seminar progress presentation for final year projects. And today we have two presentations. Without spending much time, I'm going to allow them to present so that you can see what they have to show us today. So to you, let me just make you the host. Yeah, to you, Jesse, you are now the host. Okay. You can make your presentation full screen and then you can start showing how far you have gone with your project.
Okay.
All right. As you're presenting, you can put on your video. Okay. Because it's a practice. Anyway, finally, you still have to show it during the final presentation.
Yes.
Okay. So first, make your video full screen. I mean, presentation mode. Yeah, I can see you're in PowerPoint.
Yes.
That should be very easy. That should be very easy. Just go, at the bottom there, and then you make it a presentation slideshow. Good. Then also show us your video so that we can move on together. Okay.
That's what I'm trying to put on.
Okay, if it's too much, then just proceed. But know that in future you'll have that. Maybe your background is a bit busy.
Yeah.
But I'm saying you should improve your skills, tech savvy. You just need, like the way you see me when I put the video on, you don't see what's in the background because I've placed a virtual background. You can do that, right?
Okay.
Or you think this is my office like this?
I thought so.
This is a virtual background, huh?
Okay, sir.
Okay, so carry on so that we don't spend much time.
Okay. Our research topic was mixed design of concrete using volcanic tuff sand, presented by Jesse Mureithi and Peter Jeru. And I seek apologies for Peter, who is not feeling well. And our supervisor is Dr. Naftali Kadimba. Daktari.
What's up?
I think this thing is jumping,
It's jumping because I had you clicked the cursor too many times.
Oh, so I should click once.
Of course, if you click 2 or 3 times, it's going to go to the next slide and the other one. You see, I'm not wrong. The way I'm telling you, you need to up your game in technology a little bit. Yes. Because even in the final presentation, in the other presentation, when you're presenting to the other panel, I noticed you usually have issues with either your internet or the speed with which you connect, and you have limited time. All right.
Okay.
So you need to do. I mean, try. I know you might have. This technology might have gotten you in school, is it? You are mature entry, eh?
Yes.
Yeah, but you need to up your game, my friend. Huh?
Yes. Okay, maybe I can start now. I'm ready.
Yeah, so go next quickly.
Okay. Our introduction, which is popularity of concrete as construction material, which has led to demand of concrete and excessive use of sand as fine aggregate, thus needing an alternative sand to use, which has led to choice of volcanic tuff sand in replacement for river sand. Concrete is one of the most widely used construction materials. As according to Yankee in 2019, there are dynamic phenomena which affect concrete directly, which include earthquakes, storms, flooding, and ground movement. Material quality is an essential factor in structural design, which has led to various testing, leading to pressure testing equipment which can be used to control the quality of concrete. There are primarily two qualities of concrete, which are durability and strength. Durability is the resistance of weathering action due to environmental conditions such as temperatures, humidity, chemicals, attacks, abrasion, and frost, and the rest. Strength, it is the ability of concrete to resist bedding after loading is applied to it depending on the specific concrete mixture. There are various testing methods for concrete strength, which include destructive tests, semi-destructive tests, and non-destructive tests. The estimation of compressive strength of concrete, we relied mostly on destructive tests and non-destructive tests. Non-destructive tests, we were able to determine the compressive strength test, tensile test, and friction test. In non-destructive tests, the equipment used are Smith hammer, ultrasonic pulse velocity, core extraction for compression stress test, and others. Combined method of ultrasonic pulse velocity and rebound hammer test. But in our project, we took the Smith hammer or the rebound test. Problem statement. Recommended materials properties of volcanic tuff sand at 4% with partial replacement has led to evident disregard of volcanic tuff sand in full replacement, which has led to our current study to identify the required mix design in proportion for the volcanic tuff sand. Main objective, to evaluate mixed design of concrete using volcanic tuff sand as fine aggregate. Specific objective, to compare properties of volcanic tuff sand and sand as a replacement for river sand in concrete components. To obtain proportional mixed design of concrete using volcanic tuff sand. To determine characteristics of fresh and hardened concrete using volcanic tuff sand. Scope of the study. Study is limited to examination of utilization of volcanic tuff sand as a replacement for river sand and its consequent mixed design. The study focuses on mechanical and physical properties of hardened concrete using volcanic tuff sand. Concrete is made up of mixture of water, fine aggregate, coarse aggregate, and cement. In our summary of empirical review or literature review, we had the Alawade 2011, who their study title was the effects of water cement ratio on compressive strength and workability of concrete and italic concrete mixes, where their objective was to measure the effective of cement ratio on concrete strength and workability. Their findings was that in the variation of compressive strength of concrete and italic mixes investigated, the research gap was focused on water cement ratio for concrete and italic mixes, but they did not provide an adequate insight on use of tuff sand. In our current study, we are going to have contribution there on the providing evaluation of mixed design of a concrete using volcanic tuff without replacement. JDD 2018, their topic was evaluation of the concrete quality using destructive and destructive test methods, and their objective was to evaluate the concrete quality using destructive and destructive tests. Their finding was that the concrete strength is determined by the paste strength and artificial bonding characteristics. The research gap the study focused on concrete strength and does not emphasize on the choice of aggregate use. But in our current contribution study, the study focuses on not only on concrete strength, but specific the use of volcanic tuff aggregate. Clover 2011, they were having property of fresh hardened concrete cement concrete research, which their objective was to establish the mechanical and physical properties of fresh and hardened concrete. Their research gap was relied entirely on review of a past literature to draw conclusion and inferences. In the current contribution study, we will have to adopt an experimental approach to obtain the new knowledge to complement earlier research. Holler 2011, also they had a state-of-art of non-destructive methods of diagnostic test of building structures and anticipated development trends. Their objective was to find out non-destructive diagnostic techniques of testing building structures. Their findings, they found that development of non-destructive techniques is skewed towards structural elements in concrete. Their research gap was they focused on techniques for detecting defects using imaging of the distribution of elements. In current contribution study, the study will adopt an experimental approach to test the mixing design. In our methodology, the fresh concrete will have the SAM test, which will go in hand in testing the workability of the concrete. The workability of the concrete, it is the property of freshly mixed concrete, which determines the ease and homogeneity with which it can be mixed, pressed, consolidated, and finished. And this workability mostly is affected by the coarse aggregates, fine aggregate, and water cement ratio. In hardened concrete, there are two tests which we have carried out, which are Smith hammer and universal testing machine. In Smith hammer, we are able to obtain the compressive strength, consistency of the concrete formation, and edge of the concrete. Using the universal testing machine, we were able to determine the compressive strength, tensile strength, and flexural strength. In determining the specific gravity of materials, we obtained the following specific gravity for the materials that we had, which is riverside, which obtained about 5% of the, which entails that 5%, which is interpreted as 2.46 specific gravity. Volcanic tuff sand, which is 27%, and which when it's interpreted, it is 1.84. Nakoa's aggregate, which is 38%, and as interpreted, leads to 2.62 as specific gravity. In water absorption of the materials, riverside had a water absorption of 1.01%, volcanic tuff sand had 13.51%, and coarse aggregate had 2.38%. In particle size distribution of the materials that we carried on the lab using the sieve analysis, the particle distribution of the riverside is as shown on the graph indicated, and we have the the particle distribution of the riverside enclosed by the two envelopes, which were having the upper limit and the down and the lower limit. Consequently, the volcanic tuff sand also we did the sieve analysis, and it's as shown on the graph where we have still embedded in the envelope of upper and the lower limit. Also, the quartz aggregate, we did the analysis and we found it still within the embedded envelope of upper and lower limit. In mixed design of the concrete, first and foremost was to obtain the characteristics of strength of the concrete, which we noted that 48.83% of the material passing the 600 millimeter sieve, the specific gravity of all materials, target mean strength. Also, the strength of the 28 days is read on the table of compressive strength, where cement class type of coarse aggregate is required. Then we have to obtain the standard deviation, and after acquiring the required, the value is applied in the figure of the relationship between compressive strength and water cement ratio to get the ratio of water being used. From then the stage 2, which comprises of water, cement content, and water content, then leading to wet density of the concrete and weighing of all materials. From the table of the slump and VB time and size of aggregate used, we were able to obtain the values of water content required as, and which was found to be 210 kilogram per meter cubic. For this value, we were able to calculate the amount of cement needed, and as the value of water content, water content, we found that 404 kilogram per meter cubic was required. Cement content, also we are able to calculate it as we have a formula which we calculate the cement content equals to water content over water cement ratio. In our stage 3, from the information we already have of the water content and its specific gravity, we were able to determine the wet density from the figure of relative density of combined aggregate to water content, and thus we found to have a wet density of 2,200 kilogram per meter cubic. On this stage, we were able to determine the total aggregate required to and obtain by subtracting cement and water content from the wet density to obtain in the previous stage to obtain the amount of all wet materials required, to obtain the material required to have the mix design. To get the proportional mix of the design, we had first to obtain the proportioning of the fine aggregate from the figure of the slump VB time and water cement ratio, which enabled us to calculate the fine aggregate and coarse aggregate required for the mix. Then so far, that's how we have gone. Those are our references. And this is our work plan, which we have starting from May to December. And we are already in progress. The ones indicated in black color, which is May up to September, we have already fulfilled that work. Now we are in the month of October, which we are still in the process of obtaining the final results so that we can have the comprehensive data coverage. And also the month of November, we have to do the final compilation and the presentation. Then December we do the submission. That is the end. Thank you.
All right, okay. Well, I don't know what to say about your progress. No, can you go back to the schedule, work plan? So where are you now? At what stage are you in as you are telling as you're presenting this?
We are in analysis and interpretation of results.
Now, in terms of objectives, you have 3 objectives.
Yes.
So how many have you tackled? What's the percentage of the remaining?
Objective we have tackled, we can say around 70%.
Around, but what do you base? You know, don't be like politicians, they just stand and then they say about 70% of this and that. Yes. But based on what? Because because I'm looking at this schedule, and that's why I was saying this schedule is a master. This is what you had submitted during the proposal.
Okay.
But when you start working now, you need to see the details.
Okay.
It's not bad if you put it towards the end, but again, let's see the objective. You say like the objective 1.
Yes.
Because you have shown us, you know, the objective was the objective 1. This is material characterization.
Yes.
Because we have seen the results for, you say you have shown us the result for volcanic TUFF, for the fine aggregate, that is the control sand and the river sand. You have shown us all those properties. Then you can say, okay, the first objective I've achieved 90%. And somebody can look at it and say, okay, for sure, these are the tests that were conducted against what was projected.
Okay.
But in that case, that's missing in your work. And I think I mentioned it in the previous presenters.
Okay.
I say this is okay. This work plan is master. This is what you had overall, but now we need to see the progress per objective.
Okay.
Because again, when I look at this,
yes,
I don't see. I see like there's some lack of sincerity, because now look at the month of September.
Yes.
You're saying, you have done testing of hardened and fresh concrete.
Yes.
You have tested of material and concrete design. You have done the analysis and interpretation of results, but you have not seen anything in the results. We have not seen the results for fresh concrete. We have just seen the material calculation for grading. That's for the fine aggregate. I have seen grading, and I think what else? The specific gravity. Those are the only 2 results that you have shown us. But now you are telling us you have all that this is covered in the month of September, last month. So is that really true?
Okay, we have done it halfway because we have crashed for 7 days and 14 days. So we were remaining next week to do for the 28 days. So we thought after we do it, that's when we will
No. This is progress. Progress means we want to see where you are.
Yeah.
I mean, what can stop you from showing us the results for 28 days? What can stop you from showing us those results versus as we wait for the 28 days? Because if I ask you, do you know why we do test at 7 days? Or even at 3 days?
3 days.
And do you know why we do this? Why? Because I mean, let me ask the general question. Why do we test our concrete at 28 days?
to determine whether we have achieved the targeted or recommended strength of the concrete.
So it's an assumption that at 28 days, we have almost towards we have attained.
We have attained what is the recommended or
required. But of course, it shouldn't be in your mind that you know that concrete continues gaining strength indefinitely, maybe, but it continues, of course, reducing exponentially.
Yes. So
it's not that after 28 days, if you test concrete at 28 days and test it at 1 year, there will be a slight difference. But we are saying it have achieved, I mean,
yes,
the highest percentage over 90% have occurred. Yes. So our target mean strength is expected to be achieved at 28 days. Now, if that's the case, why do we do the test at 7 days, at 14 days? Why don't we just wait at 28 days?
It's monitoring if it's progressively to attain the strength.
So if it's for monitoring,
yes.
How do you monitor? Like if you get the strength at 14 days, or at 7 days,
yes.
How does that help to monitor the 28 to know whether the 28 should have achieved? Which criteria?
I bet to be guided there, sir.
You need to read.
Yes.
Because what you should know is that at 7 days,
yes,
7 days is a percentage of the 28 days. I believe either 0.67 or 67% or 70%, you can confirm that.
Okay.
So that at that day,
yes,
right? So that if you find that the strength is too low,
yes,
then ultimately you might expect, if for example, you are just dealing with normal concrete. Of course, if you deal with the early strength concrete, of course, you expect to have high strength at 30 days. But if you are just dealing with normal concrete,
yes,
then it means at 7 days, we should be able to project to see whether you are going to attain. And this helps in mixed design so that you don't wait for a whole month. And then your concrete was from the word go, the mix that you did, the design that you did, from the word go at 7 days, you could even tell that it could not give you the strength so that you can try another trial mix. So that's why we are saying this project progress, we need to see the result at 7 days. We need to see those results so that we can project, because you're doing a mixed design, so that you can start projecting to see whether at 28 days, are you waiting for anything or just concrete which has not attained the strength. Okay.
Okay.
Number two, I don't know whether I noticed this.
Yes.
But I'm looking at look at the item analysis and interpretation of results.
Yes.
When did you start your work?
We started the which date? After we finished the exam the following Monday.
No. I'm saying this work plan. This work plan covers
for the analysis.
Not for the analysis. I'm looking at the work plan.
Yeah.
I'm seeing like in the month of May 2021. That's when you are identifying your topic.
Yes.
But at the same time, you are telling me,
yes,
in the analysis and result, you had already started analyzing, because I'm looking at where the bar is starting.
Oh, okay. This one we thought when you are putting it that way, we thought it's meaning the completed work. So maybe we did not get the good presentation that we could have placed here.
I mean you are in fifth year. You are in fifth year, sure. And I know you are doing civil engineering. Is it civil engineering? Is it engineering management or civil engineering practice? You know what is called Gantt chart.
Civil engineering management.
Yes, management.
Yes,
so management. You know how to prepare a Gantt chart.
Okay.
Yeah, you know, you use the skills you learn elsewhere. Then you raise them here, because like now whatever you are telling us,
yes,
it doesn't make sense, because you are telling us at the time that you are identifying your topic,
yes,
you are already writing a concept proposal in the month of May, and you're also testing materials in the month of May.
Yes.
You are analyzing and interpreting results in the month of May.
It's true. It's true.
Yeah. So this is not a true representation of whatever you're doing.
Okay.
And at the same time, at the starting point, the start time and the end times, they don't make sense. Okay. And then again, for me, okay, that was just an oversight. Maybe we left it before earlier on. But for me, I'm concerned with, we have not seen any result yet according to your schedule. It's showing us like you have done a lot. Okay.
Okay. Okay.
So you need to address that.
Yes.
Then can you go back to the slide number 19? You've talked a lot in this slide.
Yes.
A lot. But I couldn't get what you are telling us, because this is a flow chart. There's a flow chart of how you did the mix design, is it?
Yes.
This is a methodology. This is not results. This is in the methodology. Even in your write-up, this should be in the methodology. If you want to show us in summary form, in methodology. Because I said again, if you just duplicate what is in the manual, let's say like now you're using you didn't even tell us the manual that you're using for the design. I don't know whether you are using ACI.
We're using ACI method.
You never mentioned it. I don't know whether you're using the BRE, so we don't know which procedure you are following.
Okay.
So again, I said in the mix design or in those standard procedures, we do not duplicate it in our document.
Yes.
If you want it in your document, you can put it as an appendix.
Okay.
And then in the summary form, you can mention something in the methodology. So this chart, this is not result. There's no result here. And actually, you're even talking of it was 0.46. You're talking of, I don't know, you obtained this, but there is nothing we are seeing here. There's no result.
Okay.
Actually, for this slide, remove it. If you remove it here and you take it to its rightful position, that is in the methodology, you are going to realize that you have not shown us any result.
Okay.
So your work might not be, you might not be able to give much guidance because you have not seen any result, and you wanted to start seeing results early now so that we see whether they are reasonable, whether and then we start having the discussion of the result. But now we can't. Okay. Don't just say okay. You need to do the work hand.
Yeah, it will be done by end of this week.
Then as you do so, I want you to see some improvement on. Go to result on number 14. I think this 14 is where now you start your result.
Yeah, there.
Can you go back one slide?
Behind.
Okay, that you started. Yeah, okay. So move to 14. Again, I'm wondering, you are talking of specific gravity of materials.
Yes.
There's a way you are discussing this,
Yes.
And I was wondering, is this the best way to discuss? Like, are they related? The specific gravity of, you're talking of that 8%, that 5% to 27%. It's like you want the specific gravity of the whole coarse and fine aggregate to be equal to 100%.
Oh, okay. That's
I mean,
that's what I had thought. That in a chart it should add up to 100%.
That's a discussion I don't, it's your research anyway, and I can't refute everything, but I want to understand your logic. I want to understand you.
Okay, because my logic on this one, in the presentation in the chart, I thought if I use the pie chart should add up to 100%, but on my right hand side, I have placed the specific gravities as the way I acquired them from the lab, the 2.46 and 1.84. But in the presentation in the chart, when I put it directly the way they are on the right hand side, I thought it's not presenting a pie chart.
I'm not sure whether the pie chart is the correct method to discuss this result.
Okay.
Because a pie chart shows us it's a proportion of, it's a part of. I don't see the reason why you should say that they should add up to. Okay, yes. I mean, when you put a chart that like it summarizes, graphical presentation, they attract people. But somebody try to understand the logic behind that. Because what I know, the specific gravity of material, you are just characterizing the aggregates, and then you can, like now we should be having this,
yes,
versus what are the typical range. Like you want to know whether your material satisfies.
Yes.
Right? And I wish you, I don't have that slide, and that guy did not share with me. but there's a master student doing this, doing something with the material, and he had a chart whereby for every property that he is assessing, then he have what the standard, the code says. Whether be it BS, be it the ACI, be it our design manual here, you know, if you can, but Kenya standard we mostly we use in timber design.
Okay.
So that now, if you find like the riverside is 2 point, like now I'm saying your riverside is 2.46.
Yes.
And then normally sand we have it at 2.7. But look at that range, and then you can start saying, you can start now thinking, because now you have to understand, apart from just showing, because whatever you have shown us is just result. What do these results mean? What is it about the specific gravity? You know, specific gravity is about the density. This result to the density of concrete that you're going to have. So if for example, we bring pure mice here, of course, we expect the specific gravity to be very, very low. Like now you can see volcanic TUFF. Of course, it's telling you, you can see it's slow.
Yes, very.
But now you want to know whether to classify, to go to the area of right wing aggregate. Okay.
Yes.
So that now when you come to the testing, if you find like the density of concrete goes high, you can explain it using the result of the specific gravity. So you first have to understand what is this property, what does it imply, and what does it mean in our concrete.
Yes.
Okay.
Okay, understood.
Yeah. So this pie chart, think about it. Just think about it.
What you have said, I have seen actually making more sense than what we have displayed.
Okay, then when you go to the next slide. About the water absorption. Again, this is what I'm saying. Show us versus the standard.
Okay.
Because now you want to see, like we are seeing volcanic tuff side, of course, the absorption is very high.
Yes.
First, we need to know whether that's acceptable. And that we can only understand within if it's within the limits. If there is. Number two, we also want to hear you explaining why, but by that being very high absorptive, what does this mean?
Okay.
And what causes this?
Yes.
That's what we call the science behind result, discussing your results.
Okay.
Okay. No, because you can just show us charts, and somebody say, even somebody not engineer can come and say, volcanic tuff side have got a high absorption of around 13% compared with river sand, and coarse aggregate have got in the 6%, and then moves on the next slide. But what does he differentiate that person from you, a researcher and a specialist in this area? You are training yourself to become a materials engineer. What can you say about this material?
Okay. About
this absorption? This characteristic, this trend, discuss. That is the part we call discussion of the results.
Okay.
And in a very summative form, not big stories, because I don't want you to do it the way you did it in the other side. You are calling results, but it was methodology, because you talked too much, but we are not seeing results. We are not understanding.
Okay.
And by the way, before I forget about the format, you don't start with analysis and result.
Okay.
I mean, the order, right? It's results and analysis, because I mean, it's like you're analyzing and then you're showing us the result.
Yes.
Okay. And at the same time, the number of significant figures on the x-axis, on the y-axis, are they crucial? That you're showing us 6.00%, 10.00. Is that significant? Do we really need to go to that margin?
The zeros I should remove.
Yeah, I know you may wonder why, but there is what we call the level of significance. Significant figures.
Yes.
Okay. Anyway, can we? So for you, what I can say, can you go to grading? This as you are discussing our result, as you present the other results.
Yes.
And I expected to have much more from you guys, because I mean, you have had a whole month since we started, almost a whole month, 3 weeks. So you should have improved based on the discussions from other people.
Yes.
All right. On this now, I'm looking at a chart which is incomplete, because there is no legend. We don't know what the blue one is. What?
Oh, okay.
And then after you do these,
yes.
you should at the same time show us, again, discuss the result. If you're saying it's within the envelope, what does that mean? If it was outside, what would he have done that you not do now? Okay. So you need to say why. Like, you just show us and then you say it's within the envelope. Then you have to tell us the meaning of that.
Okay.
Okay. And that one you cannot just do by thinking. And I'm referring you to a very good book by Neville. Yeah, in the library, Neville, or a book. There are a number of books there that are called Properties of Concrete. That's where you read and get your discussion. And also from the papers you are calling your reference, you read and get how, just look at how a paper, a good one, don't just go to any paper, but go to a good one.
Yeah.
And then look at how the results are discussed.
Yes.
Okay. Yes. They are not just presented, but you have to give an explanation, scientific explanation.
Okay.
Yeah. So improve, add more results. Let's see all those results, discuss them.
Yes.
In details, but in a summary form.
Okay.
And rearrange your work. I don't want to talk in the previous slides.
Yes.
But maybe I just mentioned because of time. Yes. Number one, on slide number 4, if we can start from there. This one I'll just mention, I'll not give you time to explain.
Okay.
On slide number 4, because I believe this one we have gone too much through it so many times. Slide number 4, you are saying concrete qualities are durability and strength.
Yes.
I mean, you said this, I didn't understand. These are the only properties of concrete that we have?
No. We said the mostly, how do I put it?
Exactly. You used that word the most, but I didn't get most what.
Yes.
So most what? What are they what about me?
I said mostly primarily 2 qualities of concrete are durability and strength.
So most primarily,
yes.
What do you say most primarily? Watch out for that, because
okay. Okay.
Because somebody may wonder, you're talking of primarily.
Yes.
Are they sure about the properties of fresh concrete, like the workability? Workability is not strength. It's not durability.
Yes.
So is it not a primary test? I mean, you need to find a proper and appropriate terminology.
Okay.
Yeah. Then next, number 5. Yeah, I found you talked so much. This background information, but you're talking so much about the methodology. These are methodology. You're telling us the tests. Yes. Isn't it? Yes. I mean, I don't know, but somehow it felt like it's the way you are talking. You are saying these are the tests that we did. I'm not saying that in the background we cannot mention about the tests for destructive and destructive, but when you start to mention that these are the tests that we did, we moved to this, then it sounds more like a methodology.
Okay.
Remember the background information is people want to understand. You are giving them some primary information so that now you can state what is your problem.
Okay.
Background information builds or prepares the audience, and it prepares you too, so that now we can see what is the problem that you are addressing.
Yeah.
Okay, then move to objectives. There, this one, to obtain. They want to obtain, Okay, I know people might have issues with that.
Okay.
For me, I don't have much issue, but I know people might have issues with that. So I was thinking, just think about it. If we say to design a mix, to design a concrete mix using volcanic tuff sand as a fine aggregate.
Yes.
To design a concrete mix using volcanic tuff as fine aggregate. Think about that.
Oh, yeah.
Yeah, I'm seeing people having so. Okay, I usually don't mind, but
okay.
It's also good to be cautious when you present it to the others.
Okay.
Then the literature review, there was a lack of flow.
Yes.
The lack of flow on the literature review. Yeah, the previous one.
Yes.
You mentioned about the properties of, in the slide number 10, you mentioned about the properties of concrete.
Yes.
Concrete composition.
Yes.
And then all of a sudden it jumps to the empirical literature review.
Okay.
I mean, it was kind of, they are disconnect. And by the way, what is this that you are saying, others 2021? I also saw it somewhere else. Others 20, who are these?
Ah, that I copied by mistake. It's me who was doing it. Oh,
You copied it from somewhere.
no, where I was doing the graphic, so I just copied the thing, and it's me who had written the order 2021.
Yeah,
It's
because
ourselves.
but you don't have anything. You have not published anything. This is an unpublished work. It cannot be accredited to anybody.
It's true. Yeah, that's
Yeah.
right. Yeah.
Okay.
Yeah.
So I mean, from slide 10 to 11, it's kind of not connected.
Okay.
I would prefer
you
just forget about the slide 10, move directly here, and then here also. It's good the way you have summarized.
Yes.
But don't talk too much. Like, don't explain. If you are saying Arawode 2011, don't explain all these things. I mean, you can talk in a summative form about it. Remember, you have limited time. You spend too much time in this slide, such that I was worried, like when you are doing the final presentation, maybe it will be 5 minutes. Yeah. So don't spend too much. If somebody is interested, I can take you back there. The summary is okay the way you've done it, but the speaking, don't spend too much time. Yeah. You can do each one of these in about 10 seconds or so. Then the last column, I believe should not be here. I believe this one should be, because after you have done empirical literature review, you need to summarize the literature review section by summary and what we call research gap. So I think you are putting it here for every. It's like you are showing what the contribution for every of these researchers, but it's better you put it in a summary form, in a separate page, and then summarize. Don't just put it underneath every author, every reference paper that you're doing. Yeah. Okay. I want to stop there because of time, but there is a lot to be done on this work. So you have any challenges that you have faced so far?
Yeah, especially on lab, but we are really trying to negotiate with the guys on lab because sometimes they are not accepting to be there on weekends, but we are really trying. And also that's the major challenge, actually. That's what we can say.
Okay.
Time. Yeah.
Okay, you really need to move faster because there's no time. But I believe the semester is ending.
Yeah.
You only have next month, and the next presentation that you are having, you should show us as over 80% of the results, so that if the panelists think there's something that need to be repeated, I mean, they should see your results so that they can tell you whether it's acceptable or you need to do some extra test or you need to confirm something. Because if you present next time with this kind of progress, they don't have results to critic or to look at. So it means by the time you are going to the final presentation, they have never seen your results. So they are seeing it for the first time. And what will happen? So many questions will come up, such that your work may be seen like it's incomplete. Yet you had your work, but because you did not show it to them in good time, you end up being bashed so much.
That is true.
So try to show. I would like that every one of you, whoever is in this in my group, by the time we are having our presentation, which I believe it should be, I'm just sensing it, but it should be in about 2 weeks' time or so. You should present, if possible, you should present almost all your results. Let it be even in the draft stage. Okay. Okay, I stop there. I believe you are up to the task. So make the improvements that are necessary. And all the best.
Okay, thank you very much, sir.
Okay, now you can make Mark. Mark, are you here? Mark, I can see you.
Yes, yes.
You are next, eh?
Yes.
Jesse?
Yes, I make them the host.
Yes, make them the host so that they can share their work. So we move
Yes.
fast.
They are the host now.
Okay, Mark, take over, and then Jesse, you can just mute yourself, and then you listen, eh?
Okay, thank you, sir, Dr.
Yeah. You are set, eh?
Yes, I'm.
Where is your colleague?
I'm
Yes.
here.
Yes,
Okay.
I'm here.
Oh, both of you are there, eh?
Yes.
Okay. So this is yeah. This is the work that we really need to see what's happening, eh? Okay, then make it full screen, eh?
Okay.
I mean presentation mode. You know how? Slideshow.
Yeah.
Yeah, from current slide. Not working.
Right. It's not.
Can you go home? Can you click home? Which is this PowerPoint? Which version is this?
Mm. A minute. Let me see if I can.
At the bottom left, eh? Yeah, that one.
Yeah, I'm try that.
It's not working. Right? Can you press function F5 in your screen? F5.
Yeah, pressed.
I don't know. It looks so different. I don't know. This might be an old one, eh? 2010.
Yes. The other laptop I used to have, the laptop I used had an issue, so I decided to get another one. I borrowed one.
Okay.
Yeah.
Okay.
Not conversant.
Okay, anyway, it's no problem. We can just show that, but although the font will be very small, right?
Okay.
Can you drag? You see on the side, where you have the small 3 dots, on the side, you can try to drag to reduce the that pen. Yeah. Can you try to drag it to minimize? Yeah, like that. Okay. Okay, at least now it's a bit better. Okay. Okay, so start.
Okay. So a project is about the structural performance of concrete beam reinforced with molten recycled plastic, waste and sand rebars. Presenters myself, Mark Minor, and Irungo Dennis Masharia, supervised by Dr. Ngathimba. So this is the content of the presentation. We have the background information, problem statement, problem justification, objective, scope and limitation. So move to the background information. Structures rely on reinforcement bars to deal with tension within the structural members while concrete is strong in compression. Steel reinforcement bars have been the main type used in construction over the years in reinforced concrete members. Research has shown that with time, steel rebar is very susceptible to oxidation or exposed to chlorides, with time which could result to structural failure. An alternative rebar to the steel rebar is necessary to deal with the cases mentioned. Molten plastic and sand mixture can be a suitable alternative material for use in a rebar. Problem statement: reinforcement bars used in construction industry should not undergo oxidation before or after casting of reinforced concrete members. Steel rebar is the most common type of rebar used, and it is affected by oxidation, which may cause structural failure. Objectives. Overall objective: the main aim of this study is to assess the structural behavior of molten plastic and sand reinforced concrete members. The specific objectives is to determine the physical and mechanical properties, determine the design methods for using this product as an alternative to steel reinforcement, to determine failure behavior of beam reinforced with a molten plastic and sand rebar. Scope and limitation. The study involves forming and shaping molten plastic and sand mixture rebar and carrying out tests in the laboratory. So the limitations we have experienced so far is that the factory we are working with requires prior booking before using the facilities. The sand and molten plastic mixture cools at a high rate, making it difficult to place the mixture and compress. Then we have type of plastic and plastic and sand ratio is limited to the company standard. So we have the literature review, where we have a study of rebars embedded in concrete during 65 years, written by UFO-GS and the others. The finding was sulfate attacks manifests itself as a progressive loss of strength of the cement paste due to loss of strength of the cement, due to the loss of cohesion between the hydration products. Then we have the next one is the chloride threshold level for corrosion of steel in concrete. The key factor on CTL was found to be a physical condition of the steel concrete interface in terms of entrapped air void content, which is more dominant in CTL rather than chloride binding, buffering, capacity of cement matrix or binders. When you have corrosion of steel in concrete, the concrete often comes into contact with water or soil containing sulfates. These ions can penetrate into the concrete and react with concrete matrix, cause expansive chemical reactions. So the research methodology, so far we've been able to prepare the molds. We mix the molten plastic and sand. We pour the molten plastic and sand into the mold as we compressed. Then we had to carry out lab tests. So this is the layout of the factory, where we have a sand and plastic mixture. This is where they're mixed. Then after that, the machine is able to crush the mixture, then heated, and the molten plastic and sand mixture comes out by the other end as shown in the picture. So this has been our mold, which are trying to improve so that we can be able to come up with at least a better length of the rebar formed. Yeah. So this has been our work plan so far. We are currently still trying to come up with a proper rebar for tests. Yes, then I believe that's it. The end.
Wow. You are very far from the. Do you think you'll be able to finalize your work in due time before the end of this year?
Yes. The problem we have actually been facing is, okay, we've tried to convince them to have to accommodate us.
Mhm.
Previously, they were rigid on the time schedule, so we had to make prior booking. Yeah.
This is Jijenge.
Yes, yes.
Of course, that's expected because you can't disrupt the schedule of a factory. Of course, this is a commercial establishment, and they are also there to make money. So, but I believe because this is learning, and the lady there, I know the owner is somebody who is open to research.
Yes.
I believe as long as you don't go there and start being bossy, they don't have they can't have much problem. Of course, adjustment is important, even going there over the weekend if that allows, or even in the evenings, because you just need to be there to make your rebars. After that, you leave the site. And remember, they might be interested. You need to document your work well. They might be interested in getting these results later on.
Yes.
Okay, now let me see if we don't have much that's going on here. But let's see the mold that you're using for making this bar. So this is a steel tube.
Yes, yes.
Steel tube.
Yes.
Then you place your molten plastic with the side inside.
Yes. Then we
How do you get it out?
We are able to open it with a grinder.
Oh, you cut okay.
Yes.
All right. Oh, the one you are showing us on the right, it's already removed.
Yes.
But why did you take just one photo, one view from the top? I was seeing like it's the steel is still in place, like it's just plastic material inside the steel pipe. So you should have taken other photos in other angles, because this is a point of interest, is it?
Yes, yes.
And at this stage, I'm wondering, should we think of going a test for the beams, or should we focus on the test on this material itself, on the bar? Because of the time issues concerned.
We can do the test on the bar.
But to do the test on the bar, it means you need to use the strain gauges.
Yes.
Which you don't have. But there is this what we call extensiometer.
Okay.
You can liaise with who is in the lab these days. It's Ken. No, it's Nani, Juma. So you can try to liaise with him and see whether you can use the extensiometer, because if we knew about this, we could have imported the strain gauges together with the masters guys who have already imported this. He's doing something on plastics. I'm looking at this work. The kind of result that you get, the substantial result. If you do the rebar only, you're going to do to get the substantial result. If you just do the tensile test without having the strain gauges, you don't get the stress-strain relationship. You just get the ultimate strength. I'm wondering whether it's anything too close to what the result for presenting. Can you go to the objectives? Or before you move from methodology,
Yes.
Can you just go to methodology? Yeah. We don't use first person, whether singular or plural. We don't say we mixed. We. Okay. Unless, of course, if you are a renowned researcher. When you are an authority in your field, that's now I find them using the first person. But otherwise, it's always good to talk about what was done, not what you did, but what was done. It's like that. It's always in that person. Okay. Something also interesting, before I forget, in the content, you guys sounds like you are still in a concept stage. You see the content slide. Yes. The content. the content, the slide that after the title slide, number 2, slide number 2. If I just look at this content, where is the literature review? Where is methodology? Where is results and discussion? Yeah, this I believe we just copied from the concept, right? You understand me?
Yes.
Yeah, this is not the content for progress. We are moving past the number 5. We are moving to methodology and all that literature review. Okay. Then when you show these slides, usually in presentation, you don't tell us, you don't read it. It's just enough to say that this is the content of my presentation. That's enough. Okay. Then let's see specific objective. They are incomplete. You are saying specific objective to determine physical and mechanical properties of what?
Of the molten plastic rubber.
Yeah, it's incomplete, right?
You've noted that.
The second one, to determine the design method for using this product. What products?
Okay, I've noted, sir.
Okay.
Okay.
That's why that objective is one I'm cautious about. Determine the failure behavior of beams. Because the beam,
yeah,
you get it, you reinforce it. Oh, I believe maybe this is what we are doing so that you can use the LVDT, linear variable displacement transducer, so that you can see the failure behavior. But I'm wondering the time for curing. Of course, you can test it at, you're not interested in the ultimate strength. You can test it at 7 days. And another thing here is like kind of, are you doing comparative? Are you comparing between normal reinforcement, steel reinforcement?
Currently, we are not comparing.
Shouldn't that have been an obvious thing?
We're hoping first to see the behavior. Yeah.
But then the guy next to you, is he okay?
Yes, he's okay.
Have you maintained proper social distance? He's coughing, and I'm worried.
No, sir. I'm fine.
You have received the jab?
Yes.
No, that's not a definite yes.
But I am A-okay.
Okay.
Yes.
All right. So think about, and again, the overall objective, when you say you want to see the multiplastic reinforced concrete members, it's kind of gives us an impression that you're going to test more than one, maybe in beams and slabs, beams and columns. So it's good to be specific.
Yeah.
Yes.
What's your title? Can you go to slide number 1? Because the overall objective is directly related to the title. Structural performance of concrete beam. Yeah, the keyword, the specific thing is beam.
Yeah,
beam.
So by the way, because this is your title, I believe you have to do the beam. But how can you fast track? How can you move with speed? How many bars have you been able to make?
We made 3.
3, okay.
Yeah, but the problem is actually we are trying to figure out how to pour into the molds as we compress, because if you pour into the mold different times, the first batch you put in cools faster than the one you're putting in later on. It forms a line of weakness at that point.
Oh. It's not possible to pour continuously.
No.
So, and for the part that you have made, for the piece that you have made,
yes.
How does it feel in terms of the strength, just by physical impression? Impression. Can you break it easily?
No.
Yeah. Because the other thing that I started thinking when I was comparing with those tiles, those paving slab, is it paving blocks
Yes.
they are making? Those ones, they have been highly compressed.
Yeah.
Yes.
But your bar is not.
Yes, that's another issue we're experiencing.
So if I ask your opinion,
Yes.
what do you think of this project that you're doing? Is it executable?
Yes.
Based on the resources that you have and the limitations that are there, it's executable.
Yes.
And you're going to get something reasonable.
The guys there, we just have to convince them. Yeah. Because we talked to them and told them, as per what we are obtaining from the mold, it's not satisfactory. So they are a bit lenient to us. They told us that maybe we need to go and discuss on how we can look at it and maybe compromise for us.
Okay. Okay. Well, I leave it at that. But I mean, I think you need to move with speed because time is not on your side.
Yes.
Yes.
At least by now, we should be having these bars in the lab. And if they allow, I think you could make slightly more than what you need. If we have some extras in the lab, it would be better, just in case of anything. Okay. If one just snaps without, without getting results, you can always use the extra, the surplus.
Yes.
So what I can say about your work is that the progress, progress is wanting yet. I understand the limitation that you might be having at the challenges, but at the same time, also take this work as something that have to be accomplished within a certain time frame. If we just call for a presentation, final presentation, and then you don't have reasonable results, then somebody will think, then why did you embark on this research, is it?
Yeah.
So you need to think about that, have that at the back of your mind, that towards the end goal is that we are going to present these results. They might not be as good as we had envisaged, as we had thought about them, but this is research, and people understand that first of all, you are limited with the finances, because if we had proper finance, adequate financing, we could even have been thinking of how do we get our own machine to melt and prepare this timber, is it?
Yeah.
So try to have, I know sometimes we talk of quality before quantity, but at the same time we need quantity. Yeah? We need to have substantial results, right?
Yeah.
We need to have something to show. Same case with the previous guy, Jesse. Like, if we just talk so much now, as you can progress, as you are discussing on the progress, as you are giving results on the progress, and also in the final presentation, the other part, chapter 1, background information, it collapses. It should be a very small proportion. It's a key area, but a small proportion. People now become more interested and focused in the result. So if you just talk so much about the critique of the previous people's work and all that, you show us the gap, then using maybe 5-10 slides, then you just show us the result on 2 slides, just 2 graphs. People will not be convinced. Right? So think about that. And try to move with speed before the semester becomes very busy. Okay? Something I just noticed,
Yes.
on the literature review, if you can go to that slide, yeah, I showed the other title findings, but there's no critique. Critique is kind of, you are telling us, yes, this is what have been done by these researchers, but you still believe there's some part that have been left. This is the part that have been left. Because when you see the critic, when you see you criticizing, like saying this something, they did this, but this was not done, there's this part, it helps you when you move to the next slide, when you're doing the summary and the research gap. It's like from the critic that you have given, now that's the where you draw your research gap from. Okay. So yeah, I can see that there's no research gap and there was no critic, and that's why your work didn't have research gap, is it?
Yeah.
If you move to the next slide, where is the research gap? It's there. Okay. Okay. You don't have it, is it?
Yes.
Yeah, you see, your work is one thing. I mean, challenge yourself with like this, because we are presenting, and that's why I said every one of you should attend. Challenge your work based on, and this is how it's not CBC, it's called co-repetitive. Challenge yourself with the other presentation that you are seeing. If you see some improvement in somebody else's work, why don't you try to work on yours so that at least you can, I mean, I will not say benchmark, but at the same time, borrow something from other people's presentation. Because what I expected, my thinking is that from the first presentation that we heard from Mohammed, it means the other presentation should continue improving based on the comments that you are giving, based on the critics that you are we are raising, you know, that improvement. But when I look at today's presentation, and I'm not biased, but they feel they are more degraded than the previous presentation, right? Especially in terms of the formatting. I mean, it's gone down actually from the one that we started with Mohammed. Mohammed was far much better than what we now am getting the previous ones, in the following ones. So challenge yourself, like, they presented like this. I have the advantage that I'm not the first one who presented, or I don't know whether it's an advantage or disadvantage, but I have that edge that I can see. I have seen what they have done, so I want to have an improvement, both in the result, both in the progress, both in the quality of presentation, right?
Yeah.
Okay, and those people on YouTube, if you have any question that you have, whether you are a member of this this group or not, just leave the comment there so that we see whether you can help you. Maybe you are at your university and then you are developing your research concept or your research proposal. I know members from Kemadi University who might watch this later. It's very important that you ask your questions there and we can address it. Okay. Before I tell you to make me the host, do you have any question on this work? I mean, any challenge?
Currently, we are just trying to improve the mold.
So, okay.
Yeah, and we have some ideas. So once we go there, we are going to implement.
Yeah, and that's the same. Like I told the other group, show us details. Like the other groups, the one that was doing plastic, I told them, this is a new work you are doing. This is not a standard thing. So we need to see even the dimensions. You can sketch, you can just draw in Word and or in PowerPoint and show us this is the dimension of the tube. This is what schematic presentation of the workflow. Because that might be, you might be like say the pioneering person in this place. So in this area. So whatever you're going to see might not be advanced result, but maybe you might help somebody who will come in the future, want to proceed with your work or your research, but now they want to have some background, some formative, some formative area or stage, the platform that now they can catapult towards their goal. So documentation is very good, showing us what are the dimensions of the mode that you choose, showing us if the photos are not very clear, why don't you have the photo and also show us as a sketch, showing us this is how we are applying the load, so that we can even see the challenges, like the challenges that you are talking of, the molten mixture and the compression, the issue of quick settling or hardening, that there is a gap shown, that there is a weakness that is shown. Show us with an enlarged image the weakness that you're talking about. People might be interested in that more even with the result, because we understand that you might not have the capability to have so much of progress in terms of the result, but let's have, whatever you do, the steps you do, proper documentation. Okay? Yeah. Okay, all right. Yes?
I was saying we appreciate your input and we are hoping to have a better presentation next time.
Yeah, and enjoy your work. Don't be stressed that, oh, we are having challenges in the factory. This is training you. You know, now you're already relating well with the people in the field. It means you can interact, yeah? You can, because after this, you're going to graduate and work out there. So take it as a challenge. Those engagement, negotiation with the factory people, take it as a platform that you, and a point of engagement. You may be surprised even after this, you may work with them later on. Yeah.
Yes.
Okay.
Yes.
Okay. All right. All right. So let's stop there for you. We'll take any question both here and also on WhatsApp on YouTube. Eh? Okay, Derito, you are asking, can I ask a question as a follow-up from the previous? Yes, you can. Yes, you can.
Good morning, Dr. Ari.
Morning.
I wanted to ask, we were supposed to carry out a tensile test on the plastic number.
Oh, yes.
But it is like, it cannot be found anywhere in Kenya, because even the cabs, we were expecting to find the machines, they don't have, because this is a new material.
Wait a minute. You are saying they don't have tensile test for TIBA at cabs and Kefri?
No. Kefri, they have, but the machine does not work. It has a problem.
So you're saying if now I want to do a tensile test on a TIBA specimen, I cannot do it in Kenya?
From Kefri and cabs, it is not possible, even at UN.
Okay. Well, we understand, because you are the graduate and also you are the funding is not adequate for you.
Yes.
Otherwise, we would have fabricated our small tensile testing machine in JKUAT, and then we could have seen how to move about it.
Okay.
But now let me ask you now. What result are you going to show? What do you have now?
Compression and bending. Yes. And we are also supposed to carry out the cost analysis.
For the comparing TIBA and that.
And the plastic, yes.
But the cost analysis, we said, actually, that was a question I was asking. What are you going to compare versus what? Is it a member of the same cross section or a member that can carry the same load?
Is a member of the same cross section.
That's not correct. Because they don't have the same strength. They don't have the same PNA capacity. So if you take a cross section 100 by 50, for example,
yes,
but that 150, you will find like the 150 for recycled plastic will be cheaper than TIBA, is it?
Yes.
But my question is, when you design, do design with that member for the plastic be able to carry the same load as that for TIBA? If not, you are comparing. You are comparing. Instead of comparing 1 kilogram of feathers and 1 kilogram of sand, you are comparing 1 meter cubed of feathers and 1 meter cubed of sand.
Okay.
Is it the same comparison?
It is not the same.
Yeah. So think about that.
Yes.
And also think about the quantitative work. I know, and I said this in the previous group also. I know you may say quality, but I mean, if all your research that you have done in a whole year, you just show us just two slides. I mean, you talk so much on the background and all that, and then you just show us 1 or 2 slides on the results. Eh?
Yes.
I mean, people will be, they'll be kind of skeptical.
Okay.
They'll feel like, this guy he didn't do good, what do you call it? Good feasibility studies. Because you remember the very first time the video that we started on how to get a good topic?
Yes.
We talked of the feasibility. You also have to analyze. Remember, like when we are starting,
yes,
I gave you some idea, and
yes.
others you came up by yourself. So the next stage was to start conducting feasibility studies of is it viable? Can it be executed within the confines of one available equipment, within the confines of time, within the confines of budget? Can it be executed?
Okay.
Yeah.
So can we use secondary data to analyze the tensile tests from other researches?
It's okay. I don't have a problem.
Yes.
But do you have data for plastic plumber? This is the one that you are putting steel strands. Actually, those one you cannot call them fiber no more. The way I found you positioning them.
Yes.
We can only talk of strands. And now you can talk of strands. You need, like the way you position them. I still have your specimen, the one you gave me, and I'm looking at it like it's more of, you see the way we put reinforcement strands inside like the way you talk of pretensioned or post-tensioned concrete members.
Yes.
That's the same principle that you're doing now. It's not the way we are saying. We want to have some discrete short length fibers, still from recycled waste tire fibers. So it's no more. It will no more behave like that.
Okay.
Yeah.
So should we change how we are putting the reinforcement?
But you told me the issue of challenging pressing them because you can't mix.
Yes.
It will harden.
They cannot. It will destroy their machine.
No, of course, they cannot allow that. I was thinking maybe, but the way that molten, I have seen it again. The way that molten plastic is coming out, it comes out very, very viscous, very thick. I thought that it would be not even visc. It's almost in a hard state. How can we say something that you can hold by hand and mold? I was thinking that it will be something slightly light, something that is flowing, molten, flowing.
We tried for the one for flowing. It was not very good.
Okay.
Because it burns and it becomes ash and it has no property at all.
Oh, it becomes ash.
Yes, it cannot work at all.
You guys, why are you hiding those information? Now somebody else who want to do that will start repeating the same. That's information that if you tried that, did you take photos?
It was on an improvised skill.
Those are things that you need to document. These that you need to put into into the record, such that somebody else who might come and start doing this work will not do that because you already know that this cannot give me good result. Because even for me, my idea was like, if you can have it in molten state, then you can like kind of sprinkle. You apply the first day, you sprinkle your fibers there. Yes. Then by the time it's hardened, they harden together. That was my thinking.
The observation